The first type of problem we're going to review is how to solve inequalities. So we're going to take this inequality, we're going to solve it, find all the values of x that make this inequality true. Then what we'll do is, just for fun and practice, is we'll graph the solution set on the number line, and then we will write in interval notation its solution. So to start out with a relatively easy one here, we've got 3 minus 2x is greater than 1. So you might remember how to solve linear equations. I won't review that. I'm expecting that that's something that you are comfortable with. So how do you get x alone on one side of an equation when it's just x to the first, like when you're just isolating it? There's just one extra thing that you have to worry about when it's an inequality. So the idea is to just isolate the x. So we've got this 3 and this minus 2x here. I'm going to leave this negative 2x here on the left side, and I'm just going to bring that 3 over to the right side. It's added right now, so to undo that, we're going to subtract it. And I can do that on the left-hand side of the inequality, as long as I do it to the right-hand side as well. 1 minus 3 is negative 2. Okay, now to undo this negative 2 multiplied by x, what we need to do is divide by negative 2. Because then that will cancel out or divide to give us 1x on the left-hand side, or just x, and that's what we're looking for. And I can do it on the left-hand side of the inequality if I also do it to the right-hand side. The only thing we have to remember here is that when you divide by a negative number, you have to flip the direction of the inequality. If you multiply, flip direction of inequality. If you multiply or divide by a negative number, you have to do this. So this will just be positive x on the left-hand side, but this will become less than now, and negative 2 divided by negative 2 is positive 1. So here is our solution to the inequality. But we just spent a lot of time talking about intervals and interval notation. So we want to be able to fluently represent this on a number line and also using interval notation. I like to draw a number line to help me figure out how I would represent this inequality. Okay, this is an inequality right here. How do we represent this in an interval? Okay, so I'm going to just sketch a number line, and I'm going to make sure that 1 is kind of centered on it. We usually put it at 0, but I know that 1 is the point where I'm going to want to draw, and I like to just draw a few numbers in here on either direction, just so that we can, have a reminder of what the number line looks like. Okay, all numbers that are less than 1. So here is 1. Less than 1 is 1 and to the left of it. Okay, I'm not including 1 here, so I'm going to put an open circle at 1, and then I'm going to shade everything that's less than 1. So that's all this stuff down to the left of 1 here. You can put an open circle here, or in the previous slide here, we just saw that we can also put a parenthesis if you like. Okay, so this is a graphical representation of that same inequality. X is less than 1. And to put this into interval notation, we just need to remember a couple things about that. So we need a starting point and an ending point. Okay, here our ending point is 1. And we don't have a starting point because this just goes on and on and on. It starts, in quotes, quote unquote, starts at negative infinity. So we put the starting point first, so that's negative infinity. We put the comma, and then we put the ending point after that. So negative infinity, comma 1 means all numbers that are less than 1. Negative infinity can never be included in an interval, so that will always have a parenthesis. 1 is not included in our solution, so we will just have a parenthesis there too. So here's an interval notation, our solution to this inequality. Here we're going to solve some more inequalities, graph the solution on the number line, and then remember to put our solution in interval notation. Our first inequality is x plus 1 is less than negative x divided by 3. So here we've got an x in 2 spots. We've got one here, and we've got one here. So we want to eventually combine these x's together. You might also notice that there's a divided by 3, and that might make you a little uncomfortable or maybe nervous. Here's a quick way that you can actually get rid of that fraction and not have to deal with it anymore. When you have it divided by something anywhere, you can do something called clearing the fractions. So in this case, we can get rid of this divided by 3 if we multiply by 3, because 3 divided by 3 gives us 1. And when you divide something by itself, it cancels out in the sense that we get 1 when we do that. I can do that here, but I'd have to also then do it to the other side. And I have to put that x plus 1 in parentheses because that's the entire left side of the inequality. So here we have 3 parentheses, x plus 1 is less than negative x. Okay, we have to get these x's together, but this x on the left side is all bundled up in parentheses here. So we're going to need to remember the distributive property, which means to take this 3 and multiply it through inside the parentheses. So this will give us 3x plus 3, and then we've got less than, not doing anything to the right-hand side. All right, it looks like we can now combine the x's together and get them alone on one side. There are a couple ways you could go about this. I like to always have x's on the left side of stuff, so I'm just going to add this x on the right-hand side. So that cancels out there. And I'm going to also do that to the left-hand side. Now, when we do that to the right-hand side, we've got negative x plus x. That doesn't just disappear. It gives us the number 0. So that we have 0 on the right-hand side. 3x plus x is 4x. Okay, now we'll just try to isolate this x that we have just a single term of now. So I'm going to subtract 3 from both sides. That's going to cancel out that 3 on the left-hand side. And then the last thing you do here is just divide by 4. 4 is a positive number, so I don't need to flip any directions of inequalities or anything like that. I just keep it less than, so we get x is less than negative 3/4. All right, so here is the inequality solution to the inequality that we started with. It has the same meaning as the one that we started with, except it's simpler, right? This gives us an idea of what values would make this original inequality true. So let's graph this on the number line and then use that number line graph to make our interval notation. Okay, so here's 0, here's 1, here's negative 1. Negative 3/4 is almost to 1, so I'll just put that right here. Okay, I'm just going to graph, let's see, less than negative 3/4, so that's an open circle. We're not including 3/4. Everything to the left of that will be less than negative 3/4, so I'm just going to shade in just like that. So there's a graph of our solution. We do want to put this in interval notation. That's the way we want to be comfortable with. That's the goal here. So the graph can help us to get there. Remember that it's something comma something. It's the beginning comma the ending. We don't have a beginning or a smallest value, so we'll put open parentheses negative infinity. Our largest value is negative 3/4, but we don't actually get there all the way. We don't include negative 3/4, so we'll put an open parenthesis there too. Okay, so here is our final solution written in interval notation. I guess I should just probably highlight that one. All right, inequality number 2 is a sandwich of inequalities. Here we've got 1 is less than 2 minus x over 2, all of that plus 2. And then that whole thing is also less than or equal to 8. So here when we have this kind of string of inequalities or something sandwiched in the middle, we want to get the x alone in the center. So we notice it's already in the middle, so that's good. We have to get rid of all this other stuff, all the 2's there. Now we have to undo things in the opposite order that they were done in. So this would probably have come last, so we're going to get rid of that first. So you want to work on just isolating the pieces with x one step at a time. So let's just isolate this fraction with x first. That means we're going to subtract 2, not from both sides now, but from all sides. So we've got negative minus 2 here, minus 2 from that 8, and then minus 2 from the 1. And if you want, you can even put like a little dashes here or something to help you see the sides that are going on. So 1 minus 2 is negative 1. We've got 2 minus x over 2 left in the middle because of this cancellation here. Then we've got less than or equal to 6. Now I know we had a negative here, right? We subtracted 2, but we didn't multiply or divide by -2, so the signs of the inequalities are staying the same. The directions of the inequalities are staying the same. Okay, now we've got it divided by 2 in this fraction here. I know that that's a little uncomfortable for some of us. You can just get rid of this fraction. I don't mean just erase it. I mean we can get rid of it using a mathematical way of clearing the fraction. So let's just say, dividing by 2, I'm just going to multiply by 2. And then it'll be like nothing happened. We'll just get rid of the 2's here. So those are going to cancel. If I do that, though, I've got to do it to the left-hand side and the right-hand side of the inequality. Okay, so on the left-hand side, we've got 2 times -1. That's -2. In the middle, we've just got 2 minus x now. On the right-hand side, we've got 6 times 2, which is 12. All right, we're still working on isolating this x in the center. 2 minus x, we should probably get rid of that 2. The 2 is added here, so I'm just going to subtract the 2 from all 3 sides. That cancels out on the left, cancels out in the middle. In the left-hand side, though, we don't just disappear. There is a number there, and that number is 0. In the middle, we have -x. And on the right side, we've got 12 minus 2, which is 10. We're so close. We've got -x in the center, though. We do want to get a positive x there. So the very last thing to do is divide everything by -1. So that -1 divided by -1 gives us positive 1x in the center. 0 divided by anything gives us 0, so we still have 0 on the left. And 10 divided by -1 gives us -10. Okay, so here's our inequality solution. Let's graph this on the number line, and then use that graph to help us make an interval notation for the solution set. Okay, so I'm looking from, we made a mistake here. This doesn't make any sense. What number could be in between 0 and -10? Well, maybe you caught this. So the -1 here, I forgot to flip the inequality. So we should definitely do that. So this should actually be, let's see, a greater than, and then a greater than or equal to. Okay, because we divided by a negative. Sorry, I got so excited that we were solving this. We were almost there. All right, so this does not look like the normal way that we see an inequality. So here's a little trick that you can do. You can always rewrite them in the opposite direction. So what I mean by that is you can rewrite an inequality by reading it backwards. So we can swap the -10 and the 0, leave the x there, but then we kind of, read it backwards. So we've got -10. This, if we're reading it backwards, this would be less than or equal to. Then we've got x. If we're reading it backwards, this would be less than 0. Okay, so this is an inequality that is the same in meaning as the first one, but it's a little bit easier to comprehend. So this is saying all numbers between -10 and 0. So I'm just going to kind of do something like this. Okay, all numbers between -10 and 0 looks like this. Just shade in all of those. We're going to include -10, so that's a nice filled in circle or a bracket. And then we're going to not include 0, so that's a nice open circle. Okay, so here we do have a lower value, which is -10. We have an upper value, which is 0. So we write those, we put a comma between them. We are including -10, so here we have a brace or a bracket, and we are not including 0, so here we have an open parentheses. Okay, so here's our solution set in interval notation. Our last inequality is a little bit different looking in that we have a quadratic or something to the second power here. We can't just isolate an x in this case. We have to do something that's a little bit different. The way to go about this is to first get 0 on one side of the inequality. There's already x squared and 2x on the left side, so I'd probably guess we're going to get a 0 on the right side. So the way that we should do that is to subtract 8 from both sides of the inequality. If we do that, then on the right-hand side, we're going to get a 0 here. So this will be x squared plus 2x minus 8 less than or equal to 0. Okay, then what we want to do is see if we can factor the left-hand side. We are going to spend a lot of time reviewing different factoring techniques, but this technique for factoring is one that you should be very comfortable with. So when we're factoring a quadratic that has 1 in front of the x squared, we're looking for two numbers that will multiply to the last number and add up to the middle number. We normally put a set of parentheses like this. We put an x in each of those in the first term. Then we will have a plus or minus, some kinds of numbers. Okay, so the numbers that we're looking for, again, they're going to multiply -8 and add up to +2. And I think that two numbers exist that have those properties. We've got +4 and -2. Okay, so once we get 0 on one side when we're solving a quadratic inequality or something with a second degree, we want to get 0 on one side and then we want to factor. Okay, now you might remember setting each of these factors like equal to 0 and solving for x. And we do want to kind of use that property. Okay, so we want to say, so this is equal to 0 when x is equal to -4. Right? If you plugged in a -4 here, then that factor would be equal to 0. This factor here would be equal to 0 if you plugged in +2 for x. But we're not looking for when this is equal to 0. We're looking for when it's greater than or equal to 0. So we've got parts of the solution here, but this isn't all of it. Okay, we've got when each of the factors of this product is 0, because then when you multiply them, you'll get 0 out. So we have the equal to part, but now we need the greater than part. So what we want to do is use these two numbers and test some values that are less than each of these, greater than each of them, and in between. Okay, so I'd suggest that you make some kind of chart. So we're going to plug in different values for x. And we're going to see if these are solutions or not. Okay, so we've got 2 and -4. So I'm going to put them kind of in order. So we're going to need to do one that's less than -4. So I'm just going to put -4 here. I'm going to put 2 here. We're just going to need just 3 test values. So we need a number to test that is less than -4. So how about, I don't know, -5. So we're going to plug in -5 into the inequality here. So what we'll get here, -5 plus 4 is -1. -5 minus 2 is -7. And that multiplied together, -1 times -7 is +7. So is this a solution to the inequality? Meaning, is this greater than or equal to 0? Yes, right? This is good. So when we plug in a -5 here, this does work. It is a solution. Okay, when we plug in -4, we know that we get 0 out, so we could put that if we want to. It's not necessary, but we could still do that. So this is a solution. We did a number between -4 and 2. You could pick -3, -2, -1. I'm going to pick 0 because that's a really easy thing to plug into stuff. So let's figure out what that is. So 0 plus 4 is 4. 0 minus 2 is -2, and that comes out to be -8 when you multiply those. So now -8, is that larger than or equal to 0? No, definitely not. So we're not going to include the whole range of values that are between -4 and 2 because we picked a test point that is not a solution. Okay, 2 is a solution. That's what we found when we set this equal to 0. We just need to pick another value that's bigger than 2. So how about 3? We're going to plug that into the inequality here. Okay, 3 plus 4 is 7. 3 minus 2 is 1. That is 7 when you multiply those, and that is actually greater than or equal to 0. Okay, this might seem like a lot of work, but it's not that bad. It's not that difficult. It's just maybe a little bit tedious. So what we see here is that, what we have for our solution set is all numbers that are less than -4 is good, and all numbers that are bigger than 2 is good, but everything else in between -4 and 2 is no good. So how do we write that as an inequality? Well, let's graph it on the number line. I think that's helpful. Okay, so we've got -4 is an important number. I'm going to draw some stuff that's on either side as well. We've also got 2 that it's an important number. Hopefully it'll all fit here. And what do we have? All numbers that are less than -4 is good. And we can include -4. Okay, so filled in circle at 4, less than -4. Everything between -4 and 2 is no good, so I'm not going to shade between -4 and 2. That's no good. But after 2, that is good. And I can include 2 because we get 0 for that. So everything that's beyond 2 or bigger than 2 will be part of the solution set. So this interval looks kind of weird because there's 2 parts to it. So the first part here, this is all numbers that are less than -4. So the way that we write that in interval notation is -infinity, comma -4. We can include -4, so we'll have a brace or a closed bracket there. This other part of the solution set is all numbers bigger than 2, including 2. So we've got 2, which is our smaller number, comma, bigger number, there isn't one, so infinity. We never can include infinity, so always open parenthesis. Then we're going to include 2, so we've got a closed bracket there. Now, if you want to include these 2 intervals together and bring them, like conjoin them basically, or say they're both part of the solution, we just put a U in between them, which means union. Okay, so here is the full solution set to this quadratic inequality.